From now on, we will discuss what is known as kinematic analysis. Okay. Under this title, we will discuss three topics. One is displacement analysis. The second one is velocity analysis, and the third one is acceleration analysis. Okay, and we mainly focus only lower pairs. Okay, and if there is a higher pair, now we know how to convert that higher pair into an equivalent lower pair mechanism, right? So with that modification, we will do these analysis. Okay, fine. So now first let's focus on this topic, displacement analysis. Okay, or in general, let me say what are these analysis mean. Okay, we know that a mechanism receives some input in the form of motion and give out a motion in the form of a desired motion, right? So and we also know that each link will have a relative motion, and therefore if there is a motion in an input link, and what is the corresponding motion at the output, and not only at the output, what are the corresponding motions at all other links. Okay, so that's what we will discuss in the displacement analysis. And what is the velocity input and velocity output will be discussed in velocity analysis, and similarly we will discuss input acceleration to output acceleration relation in acceleration analysis. Okay, now let's see, let's begin with displacement analysis. In that displacement analysis, we will discuss a very simple 4-bar mechanism. Okay, so we know that 4-bar mechanism, it's going to be something like this, right? And that's link 1, with the length L1, that's link 2 with the length L2, and this is with the length L3, and this is with length L4. Okay, and that's a constrained motion, which means the degree of freedom is 1. Constrained mechanism, right? Say this L1, L2, L3 and L4 are given. Okay, and also but that's not enough, because the configuration will be different, and it depends on one independent variable, right? Because while it's changing its configuration, these L1, L2, L3 and L4 will not change. So I have to specify one more variable in order to specify its configuration. Let's say that independent variable is that length theta. Okay, let's call that angle theta. So theta is also given. Now I need to know what's the configuration of this mechanism. By that I mean, what's the position and orientation of each link. Okay, so now the question is, find the configuration of the mechanism. Okay, let's see how to do it. first let's mark a point, okay, and that point is O2. Let's call that as O2, and let's call that as O4. Let's call that as A, and let's call this as B. Okay, maybe I will draw somewhere here. So that's our O2. Okay, now what am I going to do is I am going to draw O4. And how to draw O4? I know L1, so let me draw a horizontal line. Okay, let me draw a horizontal line, and I'll mark a point somewhere in the line which is L1 distance far from this particular point O2. Okay, let's say it's here. Okay, so that is the point O4. Okay, so that's our point O4. Now we need to identify A and B. Okay, once we identify A and B, we can join all these points, and that's the configuration. First, let's see how to identify the point A. Okay, so now we know this theta value because that's given, and L2 value that is also given, right? So let's take an angle theta and draw a line segment with the length L2. So that will be somewhere here. Okay, so that's our point A. Okay, this is our point A. Okay, now how to identify point B? Okay, so how to identify point B? Okay, because I do not know the angle of this the horizontal line and this link 4, or even I do not know that what is the orientation of L3, right? If I know those things, then I can easily identify the point B. Since I do not know, I can't use that idea. So what I am going to do is I am going to draw a circle with the length with the radius of L3 and with the center of A. Okay, and with the center of A, I'm going to draw a circle. So it's going to be something like this. Okay, so what does this circle means? It means, say so this linked length has been connected with the point A, right? And what are all the possible path it can go by fixing this angle theta? Okay, if I fix this angle theta and say this connection is not there, okay, this kinematic pair between L3 and 4 is not there, then these are all the possible locations B can be, right? Now let's do the same thing with this O4 as a center and L4 as the radius, and if I do that, I will get one more circle, and the point B is the point where these two circles intersect. Okay, so if you see where it's being intersected, one is here and another one is here. Okay, so now among these two, which one is our B? As a matter of fact, both can be B. Okay, so if we have some additional information, then we can choose among these two which one is B. Otherwise, both the things are our solution. Let's say let me assume this is going to be our solution, which means I can connect like this. Okay, so that's our point B. Okay, so now so once we identify the point B, now I know what is the orientation of link 3, and also I know what is the orientation of link 4. Okay, and I'll do one thing. Let me call this as theta 2 and let me call this as theta 4. Okay, so if you see in general, theta 2 will be the input position. Okay, and theta 4 will be the output position. So sometimes we may require to know what is the output position, or output position of position for this mechanism or this particular link, okay, for a given input, which is theta 2. So that could be one kind of question which we need to answer. So even for that, what we have to do, we have to construct this mechanism and identify its configuration. Okay, fine. Now let's do the same for a slider crank mechanism. Okay, so how the slider crank mechanism, so it's some sketch, let me put, and let me draw slider. Okay, okay, so that's our slider. So this is link 1, this is also link 1, and that's link 2, this is link 3, which is our connecting rod, where the link 2 is the crank, and this is link 4. Okay, and if you see here, what are the things we know? We know, let's say we know L2, the length of link 2, L3, the length of link 3, and one more dimension, which is this gap, which we call eccentricity. Say we know E as well. Okay, so these are the things which will not change. Okay, now in order to define the input motion, or even for this case, this F is equal to 1, right? That independent variable to define the configuration, that independent variable which I am going to choose is theta. Okay, and what is the output variable? The output variable will be this position of the slider, maybe position of the slider from here, from the let's call this as origin, so let's call that as S. So for these things, okay, what is S? The position of the slider, that we need to identify. Okay, and let's call this as O2, let's call this as A, and let's call this as B. Okay, now let's see if L2, L3 and E is given. along with theta. Okay, let's see how to construct this configuration, and once we construct this, we know what is S, right? So let's try to construct it. So once again I can choose my theta, sorry, O2 anywhere. Okay, and I'll do one thing. I will just put a horizontal line which passes through this point O2. Okay, and then what am I going to do is I'm going to draw a line parallel to this line. Okay, parallel to this line with the distance E. Okay, with the distance E. Okay, so this distance is E. Let me extend it. Okay, because that is the line where the slider is going to be. Okay, so somewhere in this line the point B is going to be. Okay, now first let's identify the position of point A. So to identify the position of point A, all I require is L2, which is known, and theta, which is also known. So from this I can identify, I can draw a line segment. Okay, let's say that's our A. Now the point B I can identify by drawing a circle, okay, or a circular arc with A as a center. Okay, with A as a center and L3 as the radius. Okay, if I draw that arc, let's say it's going to be something like this, but it is going to intersect this line, this horizontal line, at two places, maybe over here and then maybe somewhere over here. Okay, so which is the solution? So whether B is going to be here or here. As a matter of fact, both can be a solution. So let's say if one solution is here, then slider is going to be like this. Okay, the other solution, maybe for other solution I will change the color. For other solution it's going to be like this. So that's our second solution. Okay, maybe so that's our second solution. Okay, similarly we can also draw the second solution for 4-bar mechanism, which is okay, that's our second solution. So this is our second solution, this is our first solution. Okay, so yeah, so once we construct it, let's say first solution is the solution which we are expecting. In that case I can identify what is S. Okay, so which is just this distance S, right? So that's how I can identify S for a given theta. Okay, let me change the color. Okay, I can identify S for a given theta. Okay, now we will be very much interested in, for example, in a 4-bar mechanism, theta 2 for different values of theta 2 and what is the value for theta 4, or in other words a plot, okay, where this is theta 2 and this is theta 4, so that I will get a relation, right? And similarly for slider crank mechanism, for different theta, what is S, right? I'll be interested to know that. Okay, how can we identify? By the way we have identified the solution is known as graphical approach, because we have drawn things and we have identified the solution. Therefore, it is called graphical approach. Okay, which means there is something called analytical approach, and we'll see those things later. But graphical approach is a very important, and it will give an intuition. Okay, so now in that case, how can I identify the relation? So to identify the relation, we have to construct the configuration for the mechanism for different value of theta 2. Okay, and for different value of theta 2 we will get different value of theta 4, maybe something like this, and then if we join all these things together, we'll get a relation. And the same thing goes for the slider crank mechanism as well. Okay, so that's how we construct, that's how we do the displacement analysis for 4-bar mechanism as well as slider crank mechanism. Thank you.